Typically when working with complex surfaces, we're not going to be able to use the draft tool to add draft to the part. The surfaces are going to be too complex. We're going to be more concerned with curvature once we get to the point that we've built the surface. So we're going to want to plan any draft that we want in the part in advance. And there are several ways you can do that. With the boundary surface tool and the filled surface tool, which we'll be looking at, there's different options for end conditions. In the boundary surface tool, we have options for normal to profile that we don't have in the filled surface. And if I were to use this option for the surface and increase the strength here a little bit, on the outside I'm going to have this normal to profile. So I'm going to have zero draft right at this edge, which may or may not work. And we'll be checking this with the draft analysis tool. Let's say we need 3 degrees of draft in all the cases that we're going to be looking at. We can see that because this surface tapers in, the only area that would require draft is this bottom edge. Now within these end condition options for both the boundary surface and filled surface, we have an angle control or draft angle option that I can flip back and forth, and you can see if I increase this value, it'll taper this in. So if I change this to 3 degrees and then look at the draft analysis, you'll see on this side this starts at 3 and progresses up. And we could do the same on the other side if we want. We're not always going to have the luxury of being able to choose that out after the fact. For example, here I have 4 splines that define my boundary. And if, for example, I try to use a normal to profile, I'm going to get an error message. The reason being that this is already defined by 4 splines. So if I did create this surface based on the shape of it, it would have probably plenty of draft. But let's say, for example, that we didn't have enough draft, that we changed the sketches on the sides. Maybe making this vertical as well as this. And the same on the other side. Now when I take a look at this with respect to the top plane, I can see at certain areas I am lacking draft, and that might not be a large enough area to worry about. But that's something we can build into the sketch. So instead of creating those vertical relations, which I'll go ahead and delete out, being careful not to delete out the actual spline handle. I can go ahead and add in 2 reference lines. And I'm going to go ahead and just give this an angle of 3 degrees on both sides. Then we can go ahead and make these 2 tangent, or we can give them equal curvature. And now if we look at our surface, we should generally have enough draft. In this corner we don't, so once again we'd probably have to make a slight modification to get that to update. So we could do the same on the other side, or we could just do this manually and then take a look. So we can do it with the normal to profile end condition, or we can do it with the sketch. We can also do this or add draft by using a reference surface. So I'm going to go ahead and create a filled surface. And in this case, we're going to assume that we need 3 degrees of draft running in this direction, as well as on the outsides. So right now we're already fine on the outside since we've already added these sketches in. If I create a direction vector, for example, I can use that as an end condition. If I was using the boundary tool, in this case I'm going to create a reference surface to work off of from this sketch. And I'm also going to create an extruded surface off of this sketch. One of the benefits to working with reference surfaces is that you can access the tangency and curvature to face options for both the boundary surface as well as the fill surface. So if I make this curvature continuous, I can create my surface. And then of course if we look at the draft analysis, you can see that at the bottom of the surface we don't have enough draft because this is currently normal to, or rather curvature continuous to, a normal surface. So with this reference surface, we can go ahead and add several degrees of draft. And then if we look at that draft analysis, you can see we have enough draft everywhere but the corners. And that's probably due to the fact that it has to calculate in curvature to face on both of these. So it's having trouble maintaining that draft angle. We could just make a quick update to both of these angles. And we see we've removed some of that out. And once again, we could add more to this side. And we can keep doing this until we have a satisfactory result. So you can see this isn't quite as simple as just adding draft using this draft tool. But if you plan in advance, it's fairly simple to get the right amount of draft. Within the boundary surface option, just like the normal to profile, we also have those tangency and curvature to face options. But with the boundary surface tool, we can also add a draft angle. Just keep in mind with the boundary surface tool, of course, you don't want to create a two-sided or three-sided face. This is just for a reference.